Now let's talk about the sampling distribution for population proportion. This time, let's assume that we are interested in understanding the proportion of the population with green eye. So instead of studying everybody in the population, we take samples and we study these samples and we identify the proportion of people with green eyes in each sample. Again, population is distributed normally and the distribution is called population distribution. And if we keep taking samples and calculate the proportion of people with green eye in each sample, then we can build a distribution over this p-bar values, which we call that sampling distribution of sample proportion. So we have a population which is normally distributed with the mean of mu and a standard deviation of sigma. We calculate the proportion of people with the specific features like having green eye. Random variable is the proportion of people. We take multiple sample and calculate the proportion in each sample. The mean of the sampling distribution or mu sub p bar is equal to the p, the proportion of the population. And a standard error of the sampling distribution or sigma sub p bar is equal to root square of p multiplied by 1 minus p divided by the sample size. So both distributions are normal, and as we increase n, this distribution gets narrower and narrower, and that means that the proportion of sample or most of these samples have a proportion equal to the proportion of the population. Central limit theorem for sampling distribution of proportion tells us that sampling distribution of sample proportion or p-bar is normal if these two conditions are satisfied. N multiplied by p is more than equal to 5 and n multiplied by 1 minus p is more than equal to 5. In another word, for large n, these two equations are satisfied, therefore sampling distribution is normal, and we can use normal distribution feature to answer any probability question. In order to answer to the question regarding the sampling distributions of proportion, these are the steps you need to take. Step 1, check if sampling distribution is normal by checking these two conditions being met. Second, update the features of sampling distribution. If population proportion is p, then sample mean is also p, and sample standard deviation is root square of p multiplied by 1 minus p divided by n. Now that we have the mean and a standard deviation, we can formulate the target probability and use the z-score method or Excel function to answer the probability question. Let's look at this example. Study found that 55% of British firms experienced a cyber attack in the past year. The number of firms experiencing cyber attacks are normally distributed. So we know that the population is normally distributed, and 55% is actually the population parameter or P as the proportion of the firms experiencing cyber attack. We take sample of 100 firms and we study what percentage of them are experiencing cyber attack. We can update the mean and standard deviation for sampling distribution. Expected value or the mean of the sampling distribution of proportion equals to this p, 55%, and the standard error of sampling distribution is root square of p, 55%, multiplied by 1 minus p, 1 minus 55%, divided by n, which is 100, and that gives us 0.49. So step 3, we can formulate the probability and answer the function. Let's solve this example in the Excel. So we have a population. There is one parameter. Proportion of the population is 55%. So this proportion is P also, is 55%. We take a sample of size n 100. So the mean or E of p bar is equal to the proportion we had, and a standard error of p bar is equal to square root square of p multiplied by 1 minus p divided by n. So now I have a normal distribution that has mean of 55% and a standard deviation of 5%. Step 1, identify if this sampling distribution is normal. So sampling distribution of proportion is normal because two conditions should be met: NP more than 5 and N1 minus P is also more than 5. Let's check them. So NP is equal to N multiplied by P, which is 55 and more than 5, and N1 minus P is equal to 100 multiplied by 1 minus P, that's 45. Both numbers are more than 5, therefore sampling distribution is normal. Step 2, update the sample features, which we already did. Step 3, formulate the probability, and step 4, calculate the probability. So the question asks, what is the probability that out of that 100 companies, more than 57% of them are experiencing cyber attack? So that's the formulation. Again, norm.this will give us the yellow part. We are interested in green part. We need to transform this to 1 minus the probability of p bar being less than 57. So probability of p bar being more than 57 is this area. The area under the curve is 100% or 1. 1 minus the yellow area gives us the green area. In another word, probability of p bar more than 57 is 1 minus the probability of p bar less than 57. So I can use 1 minus norm.dist 0.57 mean of the sampling distribution, standard deviation, and true. So there is 34% chance that 55% of the companies in our sample experience cyber attack. Let's calculate what is the probability that between 53 and 60% of the companies will experience cyber attack. So again, we are looking at the between area probability. So we need to rewrite this function that's equal to the probability of the larger number or larger area, p bar less than 0.6 minus the probability of p bar less than 0.53. So larger probability minus a smaller probability gives us the between probability. Okay, so that's equal to norm.dist 0.6 comma mean of the sampling distribution, standard deviation, and true, minus norm.dist 0.53 comma mean, standard deviation, and true. So there is 49% chance that between 53 to 60% of the companies in our 100 companies will experience cyber attack. I hope now you can understand the concept of sampling distribution and how to tackle these problems in Excel.